Let's talk about a couple of learnings in this video, which I can play back from recent customer meetings. And one is around tracing packets end to end and making sure that you think about the both paths going sort of from red to green or green to red in this example. And then another learning is just remembering what tools are available to us in the tool bag of Azure Networking, and then making that decision of what tools to use through the lens of, is this tactical, is this strategic? So this customer had a interesting requirement, which was, on this simplified diagram, I've removed some of the resilience components just to make it easier to talk about. Well, they have inside of the European time zone, they have some Azure regions deployed. Inside of those regions, we have a SD-WAN appliance. So some virtual CPEs are deployed as virtual machines here in Azure. And this customer was actually running BGP over the top of IPsec to a VPN gateway that was deployed in one of the European regions. And we'll see why that's relevant in a second. This was kind of one of the patterns in the SD-WAN documentation you might have seen in the past. Normally it's replaced with things like root server or virtual WAN these days. This SD-WAN network then connected them to data centers in the EMEA time zone as well as remote sites. So sort of green SD-WAN had reachability to blue Azure regions. And all of this was working fine. So for example, if they had spoke VNets down here, which were, let's say, blue in the box here for European regions, this access was working fine. You know, these two components could talk together. We then wanted to add in a remote use of Azure in one of the Asia regions. So I'm calling that APAC here, Asia Pacific. So we deployed some use of Azure, so some VNets and gateways, etc., in those regions. And then we had P2S users in the local countries connecting into Azure there. And that's relatively straightforward. These could access the domain controllers and other things hosted in those locations. And that was working as expected. If this customer had a requirement for those VNets to talk cross-region, red to blue in Azure, then we could just follow the normal patterns, globally VNet peer the hubs, put some IP forwarding devices, maybe Azure firewalls in the hubs and route traffic with UDRs, etc. And that would all work fine. But then we get to a more interesting requirement, which is I would like my users in Asia to connect into Microsoft Azure in Asia and then be able to transit the Microsoft backbone somehow and land ultimately on applications hosted in my green data center in Europe. And that's a fair ask. So how do we go about thinking about that? Well, one of the sort of high-level principles would be, well, Azure virtual networks are by default not designed to be transitive in this way. If you connect in things to gateways here, then you can get access to hubs here, spokes here, through things like the hub and spoke story and use remote gateway. But that doesn't give you default access to things in other regions, and also onwards remote networks connected outside of Azure elsewhere. As the platform has developed over the past 5 years, we have had new features come into Azure, such as virtual WAN, Azure Route Server, Express Route Global Reach, which effectively is opening up the Microsoft network to transit network flows, to use the Microsoft network. So maybe if you were to look at this requirement strategically, the greenfield, you might say, okay, well, to enable this flow, maybe you use virtual WAN, and then you go down the path of looking at that if it's suitable. If it was Express Route, maybe if this was Express Route and this was Express Route, you might gravitate towards Global Reach. If it was Azure Route Server and you were already invested in NVAs, you might go down that path. But this customer had been on Azure a few years, and it was more about, can we get this working now in a tactical solution and then think about the more strategic solution long term? I think first of all, let's let's understand why this won't just work by default when you plug things in, and why some of the initial tools you might gravitate to might not work. So as I said, when a P2S user connects here into this gateway, it will get allocated one of these IP addresses. Therefore, this green box here will need to know that I could go to Azure to get to these IP addresses. And of course it won't do, because the only routes that this knows about dynamically are the routes that the local VPN gateway is advertising, and that will be its hub plus any associated spokes. So the green won't have any idea about how to get through to this gateway. It won't even send traffic to Azure Blue Box for the P2S users in the red box. And I mean, yes, there are solutions to that. You could start thinking about what we call ghost virtual networks. You configure a network here with the same address space as the P2S users, and that gets the traffic in here, and then you override the route to force it over the global VNet peering to an Azure firewall, etc., etc. But generally, we try and avoid those network bodgers if we can, because they're frankly a support nightmare in the future. If that person leaves the business, then unpicking those solutions is very difficult. So we have a problem from green to red. Red to green's a bit easier to solve for, actually, because we have this feature of an Azure P2S gateway called custom routes. And this lets you define routes on the P2S gateway that you can force to be advertised to your clients, regardless of if the VPN gateway thinks those routes exist locally or not. So for example, I could come into my P2S gateway here in the red box, configure a custom route that said, always advertise the 10.100.20 range to these clients. And that would at least mean they could get traffic here, and then you could use the normal tricks of forcing traffic through UDRs and firewalls to ultimately get the traffic there. But as we said, it's pretty useless if the return path doesn't work. But like I say, that was my sort of first learning I wanted to pass on, which is when thinking about these flows in Azure, and you come across this scenario quite a lot. It's kind of it's a networking thought model as old as networking itself, which is just because you can pass traffic one way, always think about the return path, right? Maybe you can force the traffic here, but if this network doesn't ultimately have reachability to the network that sourced that traffic, the return path won't work, and effectively IP networking is broken. But like I said, how would you solve for this in the long term? Well, maybe you would convert this to be a virtual WAN hub. Maybe you convert this to be a virtual WAN hub. You put them all in one common virtual WAN. Maybe at the same time you could modernize this. You could have your SD-WAN appliances either inside the hub, depending on the vendor, or they could be in a spoke that's BGP connected to the hub. So you remove that IPsec element here. And due to the any nature of virtual WAN, you would just get this behavior across the Microsoft backbone. Through virtual WAN, P2S users could come in, and that's one of the main benefits of virtual WAN. Dynamic, any-to-any routing with minimal user configuration. You have to double click on things today like firewall insertion, etc., but that's probably a step too far for this video. But to my second point earlier, let's not forget about the tools that we have available in let's say, more of the antiquated toolkit of Azure Networking, which is, well, remember this is a P2S gateway, a VPN gateway with P2S enabled. This is also a VPN gateway that's connected to my SD-WAN appliance. So these SD-WAN routes basically appear as VPN routes as far as Azure is concerned. And remember how in Azure we can use BGP over the top of IPsec to build meshes of transitive connections. This was more popular in the past before the advent of products that I've talked about. Kind of shows here the mesh of BGP VPN routes enabling Site 4 to talk to Site 5. And maybe for sure there's some caveats here: IPsec throughput, technical debt, technical overhead, etc., etc. But if you combine that thinking with the thought process behind articles like this is kind of saying the same thing. If you BGP mesh all of your VNets and then you start connecting in P2S clients, you can effectively build your own overlay on top of Azure using the native VPN gateways. So the solution that this customer will potentially look at, again for a tactical short-term fix, is this traffic here traversing to blue is relatively minimal and almost negligible. So you could even argue that this VNet peering is not required. So what if we just take this gateway here and this gateway here, and we run BGP over IPsec over the MS backbone? And that could be between the public IPs on the VPN gateway. So a Microsoft PIP in blue talking to a Microsoft PIP in red would never leave the Microsoft backbone. It's always not going near the internet. So you're going to get very good performance in terms of latency, packet loss, jitter. And one of the benefits of building that overlay is effectively it is transitive at that point. It's not like VNet peering. So these VNets will get advertised here, which will get advertised here. And this P2S user can hop here, and then hop onwards to the green network. So yes, it's a fairly sort of complicated solution with lots of cost and IPsec overhead enabled, but this is a possible solution which could get this customer out of this particular hole for this one region, which I thought I'd share with you in this video, along with the earlier lesson around just tracing the source and destination in both directions. And like I say, the one point to sort of maybe restate is don't let this get out of hand, right? If you end up having lots of these red regions, let's say you need this solution in India and South America, and of course maybe you've got 3 of the blue regions, you don't want to end up with this diagram here times 10 regions with 10 squared IPsec tunnels. That starts to become unmanageable, very costly, and taking you down into a rabbit hole of complexity. At that point you want to bubble back up to the high level decision and then look at things like virtual WAN, etc.